Here's a beautiful question to finish with. But remember what I told you. If this is a multiple angle, you have to do something first. You got to mess with this domain here first. Okay, so let's do this. Our domain now is between 0 and guess what? This is 3x, meaning that everything gets multiplied by 3. This is now a domain of 6 pi, meaning that we have 3 rotations. Oh man, that's going to give us a few extra answers, isn't it? You haven't seen nothing yet. Watch this. Second thing is you have to follow now the 4 steps. Now that you've changed this domain, stick to the plan. Follow the 4 steps. The 4 steps, the next one is to isolate. So, okay, first things first. Divide by 2, divide by 2. This gives you cos squared 3x equals to 1 over 2. Now, next step would be, of course, square root. Square root, square root. So this is now cos 3x equals to, oh, wait a second. When you square root, don't forget the square root principle. Ooh, that could have been dangerous, forgetting that. Now, if you do that, check this out. This now becomes the square root of 1 over the square root of 2. Well, wait a second. The square root of 1, what are you talking about? That's easy. Okay, so cos 3x, the square root of 1 is just 1. Don't forget the plus or minus over square root of 2. Now, you're probably saying, hey, wait a second. That's not one of the values in the unit circle. Yes, it is. You just forgot to rationalize this, right? Okay, multiply top and bottom by root 2. This now becomes plus or minus root 2 over 2. Aha. Okay, so far so good. But check this out. What's our next step? Yeah, the CAS rule. Add sugar to coffee. But plus or minus means what? It means, yup, all the positive ones, and all the negative ones as well. Oh my goodness, you're going to have 4 angles, aren't you? Yeah, you're going to have a few more than that, actually. Hang on. Check this out. So think about it. Now, solve this. Well, root 2 over 2, of course, using my unit circle, I know that root 2 over 2 is this guy right here. Let's find the theta reference. The theta reference being, of course, pi over 4. So that means there's the pi over 4. That means that's a pi over 4. That means that's a pi over 4. And finally, the final reference is that one, which is pi over 4. Oh my goodness gracious, I'm talking about all 4 corners. Okay, so let's write this down. Our reference for our first rotation then is pi over 4. Our second reference, of course, is 3 pi over 4. That's this corner right here. Our next one, yup, you got it, 5 pi over 4. And finally, our last one, which is here, which is 7 pi over 4. That's rotation number 1. But remember, this is for 3 rotations. So guess what? It's first rotation. That's got to do the second rotation. Okay, so how do I do a second rotation? You're going to add 2 pi to this. Well, honestly, make it over 4. That's times 4. That's times 4. Going to give you 2 pi times 4 is 8 pi over 4. So you're going to add 8 pi over 4 to every single one of these, right? So if you add 8 pi over 4 to that one, you're going to get 9 pi over 4 in the second rotation, 8 pi over 4 to that one, 11 pi over 4. Check this out. Again, another 8 pi over 4. This is 13 pi over 4. And then finally, the last one to that is going to give you 15 pi over 4. But remember, that's only been for 2 rotations. You have a third rotation, which means you've got to add this again. Oh my goodness. Okay, so I know I have to add 8 pi over 4, but I'm running out of room, so let's clean this up. Add 8 pi over 4 to every single one of these. Okay, if I add 8 pi over 4 to this, that means I got now 17 pi over 4. Ooh, okay, comma. Add 8 pi over 4 to that, I got 19 pi over 4. Oh, let's make that a little bit cleaner here because that looks terrible. Okay, there we go, there we go. 19 pi over 4. Add 8 pi over 4 to that one, that's going to give me 21 pi over 4. And finally, add 8 pi over 4 to that one to give me 23 pi over 4. Guess what? We're still not done. The reason why is because, remember, This is 3x. So that means you got to divide all of this nonsense now by 3. 3 and all of these guys have to all be divided by 3 or multiplied by a third. Okay, let's go. First things first, let's go. Multiply that by a third. This is now pi over 12. Multiply this by a third. Guess what? If you multiply that by a third, those cancel out to give you pi over 4. Beautiful. Multiply this by a third. 5 pi over 12. Multiply this by a third. You're going to get 7 pi over 12. Multiply this by a third. Uh-oh. 3 and 9 cancel to give you 3 pi over 4. Okay. Multiply this by a third. Okay, that's going to give you 11 pi over 12. Multiply this guy by a third, right? That's going to give you 13 pi over 12. Multiply this guy by a third. Oh, it's 15. So if you multiply by 3, 3 cancels with 15 to give you 5. So that's going to be 5 pi over 4. Beautiful. Multiply this by a third. Yep, 17 pi over 12. Multiply this by a third. Oh my goodness, I sound like I'm repeating myself, aren't I? Well, I am. Oh, multiply this by a third. 3 goes into 21. That's 7 pi over 4. And finally, multiplying this by a third is going to give you 23 pi over 12. Oh my goodness, there are all your values based on that multiple angle. Holy smokes. But how about the general formula? Well, let's go back and look at the original. Going all the way back and looking at the original, we know that this has a b value of 3. So let's figure out the period. The period on this guy, of course, is going to be, yeah, you got it. The period, being that this is cosine, okay? Being that this is cosine, the period is 2 pi over the b value. Okay, so that's all you have to add. But interestingly enough, if you look on your calculator, you're going to see that this guy and this guy both need the 2 pi over 3 added to it. Okay, I'm going to leave that up to you to figure out why. Go onto your calculator, graph this thing, and you're going to see that this means pi over 12 plus, that's right, a multiple of the period, which is 2 pi over 3, and the other answer is pi over 4 plus a multiple of 2 pi over 3. There you go in general form. What a way to finish.